Here's my first example of a second order homogeneous linear differential equation with constant coefficients. Y double prime minus y prime minus 12y equals to 0. Now, you kind of piggybacking on what we did in the last video, I'm going to create a characteristic equation. I'm just going to write that word out here this time. A characteristic equation, because I'll use that terminology as we move along here. The characteristic equation is going to be m squared minus m minus 12 equals to 0. Now, if you look carefully, here's where it came from. M squared represents y double prime. M represents y prime, and then 12 represents 12y. So, what I find really fascinating here is that we're solving this calculus type equation by using algebra. And so it's a pretty neat moment, I think, that we can use algebra to solve a differential equation. And it won't be the last time we see that either. And so anyway, the characteristic equation is built from the homogeneous equation. And I'm going to solve it by factoring, in this case, m minus 4, m plus 3 equals to 0. So we can factor that one. And when we solve it, 4 is a root and negative 3 is a root. So we could set each of these factors equal to 0 and solve. We get positive 4 and negative 3. Okay, well, that means that the solution to my problem then is going to be y equals to c1 e to the 4x plus c2 e to the negative 3x. And there we go. Now, it would be easy to verify, and you probably should try this at least once. Verify this equation, that this solution does fit that equation okay. And notice, because we have two roots, we have two separate terms here. And the powers of e are the root times x in each case. And finally, we also have two constants. So this makes some sense, these constants, because you think about that, in order to solve this equation, in a sense we have to integrate twice, and integrating twice will create two constants of integration. Well, they end up showing up here, in essence. So there's that type of problem. Now, a couple other things can go on here that will throw a monkey wrench into it. What happens, for example, if there's only one root to the quadratic equation? Or what happens if the roots are complex numbers? And so we'll deal with that in the next videos.